In this analysis, you're going to explore the relationships between individual socio-demographic characteristics and their political beliefs with the variable of interest, that's their beliefs on climate change. In order to do this, you're going to run a series of bivariate analysis where you look at the relationship between each of the variables and the variable on climate change. I'm going to show you how you do this with this video. It's a very simple technique. You're going to run cross tabulations in SPSS, and you're going to assess whether any of the associations that you observe in the cross tabulations are significant using the chi-squared statistical test. So, to start off with, you're going to find out where the cross tabulations are in SPSS. So I'm going to go to Analyze, and I'm going to go to Descriptive Statistics. You will see there's a table options here, but we're not using that table's option. We're going to go back to Descriptive Statistics, and under the drop-down menu for Descriptive Statistics, you'll find the Crosstabs option, and that's the one you want to select. So this is the dialog box for telling SPSS the cross tabulations which you want to run. So I'm going to start off by putting the variable of interest about climate change into the rows for my cross tabulation. I'm going to start off by looking at the relationship between climate change and gender to see whether there's any differences there. So I'm going to put gender into the columns of the table. Before I run this table, I need to select two additional options. First of all, I need to ask SPSS to calculate the chi-squared test. So I'm going to click on the statistics option here, and you'll see chi-squared at the top there. So I'm going to choose that option there, and then I can click on continue. The second thing that I want SPSS to do is calculate percentage distributions. If I run this table as it is, it will just give me the cell counts. But often it's more intuitive when we have survey data to actually report the percentage distributions rather than the cell counts. So I want to go on to the cells option here and ask SPSS to calculate some percentages. Now, as I've put the dependent variable in the rows and the independent in the columns, I just need SPSS to calculate the column percentages. You can calculate the row percentages and the total percentages, but the way I've set up my cross tabulation, I only need the column percentages. So I'm going to click on continue. So I'm now ready to run this cross tabulation. So this is the SPSS output for the cross tabulation. You can see there's two parts to it. There's the cross tabulation and there's the result of the chi-squared test at the bottom. So let's look at the table first. With the SPSS table, we have the cell counts. That's the actual number of respondents within each of the cells of the table. So this first count here, that's the number of men in the survey who don't believe that climate change is taking place. And then below that, we have the percentage within gender. I've only asked SPSS to calculate the column percentage. It's more intuitive to look at how this climate change question varies within gender than it is to look at how that belief in climate change is distributed between men and women. So I've only got the column percentages here. So we can see that 4.7% of men don't believe that climate change is taking place, compared to 3.5% of women don't believe that climate change is taking place. So it looks like there's a very, very small difference by gender there. And in the last column here, I have the overall distribution, which we've already seen when we've looked at the frequency distribution of the climate change variable. We can see that if we look at people who, the answer on climate change is taking place but not because of human activity, we can see there's a small, a slightly larger percentage of women believe that response. But if we look at the final category, that's the people who do believe that climate change is taking place due to human activity, we can see that there's really no difference by gender at all. So it doesn't look like there's much happening by gender in regards to belief on climate change. And this is confirmed when we look at the results of the chi-squared test. You only really, for our purposes, we only have to look at the first row in this table here. That's the Pearson chi-squared. The first value here gives us the value for the chi squared, which you can see is 2.929. The next column gives the degrees of freedom. We need to calculate the degrees of freedom, which basically refers to how many cells we have in our table to know whether this value is statistically significant or not. For a 2x3 table here, which we have for this cross tabulation, there are 2 degrees of freedom. The final column is the really important one, and this is what SPSS calls the asymptotic significance, but I'm going to call it the p-value because that's often what it's always that's what it's called. That is the measure of significance, and you need to know how to interpret this p-value or this significance value. In the social sciences, we usually take a 95% confidence level. By that we mean that we are 95% certain that the association that we have observed has not occurred by chance. Another way of interpreting that is to say that if we carried out this survey 100 times, 95 times out of 100, we would expect to find a statistically significant. We'd expect to find the same association. So we're looking for 95% significance. For 95% significance, this level of significance has to be less than 0.05. And we can see here that the p-value we have here, or the level of significance, is 0.231. And 0.231 is greater than 0.05. So we conclude that this is not statistically significant, which is what we would expect because we didn't exactly see much difference when we looked at the data in the tables. In the social sciences, we can sometimes look for 90% confidence. That means we are 90% certain that an association we have seen has not occurred by chance. Or again, if we carried out the survey 100 times, 90 times out of 100, we would expect to find the same association. For an association to be significant at a 90% level, the p-value has to be less than 0.1. And again, 0.231 is greater than 0.1. So we have to reject any conclusion that there is a statistically significant relationship between gender and age at a 90% level. So you can conclude here that there is no statistically significant relationship between gender and climate change. So let's have a look at another cross tabulation. So I want to go back to the cross tabulation dialog box. The easiest way to do that is to click on the Recall Recently Used dialog. So I'm going to click on that, and Crosstabs is at the top. It's the one I've used most recently. And this takes me back to the cross tabulation dialog box with the same settings that I previously used. I want to get rid of gender, so I'm going to click on gender and click that out. And this time I'm going to look at the relationship between climate change and age. So I'm going to put age. I don't need to go back and make any of the changes because the other changes that I've made will still be included. So I can just click on OK. And here we have a slightly larger cross tabulation because there are more categories in the variable age group. We've got a cross tabulation, and we've got the results of the chi-squared test. It's going to take us a little bit longer to understand what's happening with age because there's more categories. If we remember that overall 4% of people don't believe in climate change, 12.3% of people believe it's happening but not because of human actions, and 83.7% believe that climate change is happening to human actions. So if we start to look at ages, we can see that the youngest ages, interestingly, are more likely to believe that climate change isn't happening. Its percentage distribution there is 6.3. Then if we go down the ages, we can see that from 25 to 59, we can see that these people here are less likely to believe that climate change isn't happening compared to the overall sample. But maybe not surprisingly, we find that a larger percentage of people in the older age groups don't believe that climate change is happening. If we look at the next choice, that's climate change is happening, but it's nothing to do with human human behaviour. We see that all of the younger people here are less likely to believe that view about climate change. But again, we find that that's higher within the older age groups, and it's particularly high within the middle ages, the 55 to 59s. So finally, if we look at the final category, that's climate change is happening due to human behaviour, we can see that overall that is lower among two of the older age groups, particularly the 55 to 59 and the 65 and over. So there does seem to be something happening between age and views on climate change. And when we look at the chi-squared test, again, we can see here that the Pearson chi-squared value is 34.986. That's much larger than when we were looking at gender. That's partly due to the fact that this is a much larger table, so the degrees of freedom is larger, but we can also see that we've got a very different value here for the significance, that the significance that SPS, that for a table of this size and a Pearson chi-squared value of 34.986, the significance is calculated to be less than 0.001. And that means that if it's less than 0.01, it's also less than 0.05. So we can conclude here that the relationship that we've seen between age and views about climate change is statistically significant at a 95% level. It's also significant at a 90% level, but we don't bother reporting that if the association is significant at a 95% level. And that means that we can be 95% certain that this association has not occurred by chance, or if we were to repeat this survey 100 times, 95 times out of 100, we would expect to find this association between age group and climate change.